In today's video, we are going to cover the basics of the entity component system in Hytale and how everything around Hytale works for modding. So, have you ever looked at Hytale server code and felt completely lost, like classes everywhere, weird names like entity store, ref, component type? Well, that's because Hytale doesn't use traditional object-oriented programming for game entities. It uses something called an entity component system, or ECS for short. So you might say, hey, that looks nothing like the Java code I'm used to. And yeah, you're exactly right. And once you understand ECS, the whole code base suddenly makes sense. So that's what this video is about. This video covers why ECS exists, so the problems with traditional object-oriented programming that an entity component system solves. It's how Hytale implements an entity component system, the concrete types, patterns, and code you will encounter, the mental model, so how to think in ECS instead of object-oriented programming. And be aware, this is part 1, the fundamentals. In future videos of the series, we will build actual features hands-on. But first, you need to understand how to think about Hytale's architecture. So who is this video for? Well, you know Java or similar languages. You have heard of object-oriented programming, like classes, inheritance, and polymorphism, but we will cover the basics shortly. You want to mod in Hytale or understand its server code, but you have never worked with ECS patterns before, or it just never clicked. You don't need previous game development experience or previous entity component system knowledge or access to Hytale source code. We will show everything in this video. Before we dive in, join the community. I just started a Discord server for Hytale developers, so if you want to help build and moderate a community and talk about Hytale modding, reach out to me, join the Discord. The link is down below on my website, and also follow me on Twitter or X if you want to talk about Hytale. So let's dive right into the entity component system. Before we try to understand the problem ECS solves, let's first talk about our setup. So let's imagine you're building a game. You have a player that moves, for example, has health and can attack. We have NPCs that moves, have health, have artificial intelligence. We have maybe some projectiles that move, deal damage, and we have items that can be picked up or have models. So how would you organize this code? So quick refresher for object-oriented programming. We have classes, and classes are blueprints. They define what data and behavior something has. An object is an instance of a class, like one specific player or one specific zombie. Inheritance means a class can extend another. Class player extends character, for example. The child gets everything the parent has, plus it can add its own stuff. So this is what inheritance looks like. We have a character class, which has a property health and a method take damage. And then we can, for example, have a player class, which extends character and provides an additional property called username or respawn. So this seems clean. So what could go wrong? So inside the object-oriented approach. So let's organize our game with inheritance. We will create a hierarchy, like a family of classes. So how would that look? At the top, we would have a game object. Everything inherits from it. Then we split into movable things, players, NPCs, projectiles, and static things like buildings or decorations, for example. And you would say, yeah, that makes sense. Movable things need physics, static things don't. So this could be our class hierarchy. We have a game object at our very base. Everything is a game object. But then we split things into movable objects and static objects. And we can differentiate between characters and even then between players and NPCs. And it looks organized, but here comes the problem. So I need to add a vehicle, like a minecart or a ship. So where would that go? And that's a good question. Like, a vehicle is like a building. Like, players can enter it, and it even has an interior, but it also moves. So it needs to be under movable. But our building class is under static, which has no move method. And that's exactly the problem. In inheritance, a class can only have one parent. If building extends static, it can never be movable. We have to create a completely separate movable building class and duplicate all the building code. And that's messy. So can't we just use multiple inheritance? So Java doesn't allow it. And even languages that do have the so-called diamond problem. If two parents define the same method, well, which one wins? It gets complicated really fast. So here's the diamond problem visualized. We have a movable class, and then a character and vehicle class that inherits. So then we have a player that inherits from both. And what if both character and vehicle have a take damage method? Which implementation does player use? And this is why Java only allows single inheritance, but that forces us into rigid hierarchies. Let's make a real example out of this, the flying pig. I want a flying pig that breathes fire and can be ridden as a mount. So let's see what that needs. It's an animal, it needs flying behavior, it needs a sort of fire breath ability, and mountable functionality. In our hierarchy, where does it fit? So you would say maybe under character, like since it's a living thing. But character doesn't have flying, and flying things like birds are in a different branch. We'd need flying character, and then flying mountable character, and then flying mountable fire-breathing character. And yeah, that's ridiculous. Every combination needs its own class, and yeah, you're exactly right. And this is called class explosion. With 5 features, you could need 32 different classes. The inheritance model breaks down when features can be freely combined. So those are our problems with object-oriented programming with game entities. We have a rigid hierarchy, we have the diamond problem, we have class explosion, and even things like god classes, like base classes, gets bloated as you add shared features, and tight coupling. Moving one class breaks others that depend on it. So there must be a better way. And there is, the entity component system. It's like a different way to think about game objects. So what if we flip the model completely? Instead of a player is a character, is a movable, is a game object. So what's the alternative? We could say a player has a position, has health, has input control. Each of those is a separate piece, a component. The player itself is just an ID that links them together. So there's no player class with methods. Exactly. The behavior comes from so-called systems. A movement system finds all entities with position and velocity and moves them. It doesn't care if it's a player, an NPC, or a flying pig. And this is composition over inheritance. Instead of building a family tree, we assemble features like Lego blocks. So we have 3 pillars. We have an entity, which is just an ID, entity 4299, entity 1337. We have components, and components are just pure data. We have position with like XYZ coordinates. We have health, the current health, the max health, and we could have velocity. And then we have systems. Those are pure logic, the movement system, the damage system, an eye system. We have an empty folder, files in the folder, and programs that process files as kind of a metaphor. So when we compare that to object-oriented programming, in OOP we would say, okay, what is it? An NPC is a character, is a movable, is a game object. But in an entity component system, we say, what does it have? A player has position, has health, and has input. So where does the flying pig go? Well, we just add what we need. Our flying pig has a position, has flying, has fire, and has a mount. And components, as I just said, are pure data. They only hold data, no methods, no behavior. This is our position class, our component. This would be our health component, and this would be our velocity component, and our AI component still is just data, for example. No methods, no move method, no take damage method, just fields. Whereas systems are pure logic. A system doesn't care if it's a player, a NPC, or projectile. It only asks, does this entity have position and velocity? If yes, process it. If no, skip it. And an entity, well, an entity is just a container. A zombie, for example, with the ID 42. We have a position, we have health, we have velocity, we have AI. This is our component, those are our components with the data, and systems will process this entity. A movement system, for example, has position, has velocity, and moves it. An eye system has AI data and updates behavior, and a damage system has health and can take damage. So our flying pig problem is solved if we just break it down into separate components: position, velocity, health, flying, and then, for example, our fire breath, our mountable, and our model to display our pig with wings. We don't have inheritance, we just attach what we need. If we want a swimming pig, we remove flying and add swimming. If we want a fire-breathing player, we add fire breath to any entity. So why is this so powerful? Well, on the first hand, it's flexible. We can mix and match any combination of features. We don't have any hierarchies. We have no diamond problem and no deep nesting. It is very reusable. The health component works for players, NPCs, for barrels, for example. It is very decoupled. Systems don't know about each other. And that's very important for game development, it's very performant. Data laid out for fast iteration, and we will cover this later. So if we compare that, ECS, to object-oriented programming, we don't ask, what is this? We ask, what does it have? We don't have an inheritance tree, we have flat composition. We don't have data mixed with behavior, we have data separate as components, and our behavior is not in class methods, it's in systems. If we want to add features, we just add a component, and the flying pig is easy. So coming to the mental shift. So I stopped thinking, what type of object is this? Exactly. Instead you ask, what capabilities does this entity have? So it can move, so it has position and velocity. It can take damage, it has health. It can think, it has AI. And that's exactly how you need to do it. Think in capabilities, not categories. And that is the entity component system core pattern. Entities, systems, components. So what have we learned? Well, object-oriented programming hierarchies become rigid when features need to be combined freely. ECS separates data from logic. Entities are just IDs, containers for components, and components are pure data, no behavior. Systems are pure logic. They process entities with matching components, and composition over inheritance is the credo. Build entities from parts, not family trees. So let's look at how Hytale implements ECS. What are the concrete types and patterns Hytale uses? So we know ECS has entities, components, and systems, but how does Hytale actually implement this? Well, Hytale has its own ECS framework built from scratch. So let's start with the big picture. Where does everything live? The server has a universe. The universe contains worlds, and each world has an entity store. That's where all ECS magic happens. We have a universe, one per server. Inside the universe, we have a so-called player ref. It contains all connected players. We have player storage that saves player data to disk. And then we can have multiple worlds. And inside a world, we have the entity store. And that's the entity component system. All entities live there. So the entity store is the heart of Hytale's ECS. And the universe is a singleton. There's exactly one per server. Think of it as the root of everything. So you might ask, how do I access it? You just call universe.get. From there you can get worlds, players, or the player storage. And if you need a specific world, well, then you can call the world, just as easy like that. So the world is the game container. A world is one game instance. It contains an entity store, like all entities in this world, a chunk store, all blocks and terrain, a list of players currently in this world, world-specific settings like time, weather, and so on. Like we can get the entity store from a world and then get all players in this world with the methods you see on screen. And the player ref is the player bridge. Well, I said players are entities, but there's also a class called player ref. And that's a good catch because player ref is something special. It is the bridge between the network connection and the ECS entity. When a player connects, they get a player ref. This holds their UUID, username, and network handler, but they are not in the ECS yet. So when do they become an entity? When they join a world. The player ref then gets linked to ref entity store, the actual ECS entity. If they leave the world, the link breaks, but the player ref stays. Player ref, for example, we have a UUID, a string, a packet handler for network connection, and then inside there we have the entity when in a world. And entity store holder save data when not in a world. So when we want to find players, we can get the player ref and work with that, for example. So let's go to the core ECS types, ref, store, and component types in Hytale's ECS framework. So ref, remember, an entity is just an ID. In Hytale, that ID is wrapped in a ref, short for reference. So ref is like a pointer to an entity. And yeah, it is. Think of it as a house address. The ref tells you where to find one specific entity in the store. So can a ref become invalid? And yes, sort of. If the entity is removed, the ref becomes invalid. We can check with ref is valid, but in most cases, we don't need to. And I would like to explain more, but the presentation is clipped off. So, but as I said, you don't always need to check if the ref is valid, like when coming from events we see later. Then we have the store, the entity container. The store is where all entities in a world live. We can do many things with a store. We can get a component from an entity. We can add a component to an entity. We can remove a component and check if an entity has a component. So think of the store as the village and refs as house addresses within it. And then we have so-called component types, the fast key. So how does Hytale know which component I'm asking for? Well, every component class has a component type, a unique identifier. You get it with a static method. So why do we need this static method? Why not use the class directly? Well, performance, as always in games, performance. The component type has an integer index internally. This is way faster than looking up by class name. Hytale processes thousands of entities per frame, so this really matters. So here's how you read components. Here's the fundamental pattern you will use constantly. First, we have a ref to an entity. Then we have the store. Then we need to get the component from the store for this ref, for this pointer to an entity. As you can see, we don't use the entity itself. We just work with pointers, like the ref in step 1, and the entity store in step 2. And then when we get the component from the store, we can read data from it. In this case, the transform component, and get the position X, Y, and Z. And this is the core ECS read pattern. Get the ref, get the store, get the component, read the data. So what about writing components? Add, move, modify, add, modify, remove. So adding a new component looks like this. The entity didn't have it before. Modifying an existing component looks like this. And removing a component looks like this. So as you can see, it's relatively straightforward. So let's look at an example like the teleport pattern. So how do I teleport a player? You don't modify their position directly, you add a teleport component. So we have this teleport component we can define with coordinates where we want to teleport the player, and then we add the component to the reference to the entity. And then a system handles it. And exactly, a teleport system runs every tick, finds entities with teleport components, moves them, and then removes the component. This is the so-called component as trigger pattern, very common in ECS. So adding a component can trigger behavior. The component is like a request that the system fulfills. So let's get to system types. When does our code run? How do I make my code actually run in the game? Well, you create a system. The question is, when should your code run? Hytale has different system types for different timing needs. Need to run every frame? Use an entity ticking system. Need to run when an entity joins or leaves? Use the ref system. Need to run when a component changes? Use the ref change system. Or need to run when damage happens? Well, use the damage event system. So let's look at the entity ticking system. So let's look at a system that runs every frame. For example, we have a poison damage system, which extends the entity ticking system. We have a query and we have a tick method. So we have two key methods, getQuery and tick. So let's understand them first. What does getQuery do? Why do I need it inside a system? A query is a filter. It tells the system only process entities that match these criteria. In our example, query.and and then health and poison means only give me entities that have both a health component and a poison component. So if an entity only has health but no poison, the system ignores it. Yeah, exactly. Without the query, you'd have to manually check every entity. With a query, Hytale does that efficiently for you. And we can combine queries in different ways. We can have entities with both health and poison with an AND combination. We can use OR, which says, hey, entities that are either players or NPCs. Or we can say, hey, entities that do not have the specific type of component. And then we can say we can combine those patterns. We want like damageable entities. We want entities that have health but are not invulnerable. And that's also very, very powerful. But inside this tick method we saw earlier, there was a parameter called DT. In the tick method, what's that DT parameter? That stands for delta time, the time since the last frame in seconds. At 60 FPS, DT is about, well, 0.016 seconds. So you might ask, and I asked that too, well, why do I need that? Well, we need to make our game frame rate independent. If you want to deal 10 damage per second, we need to respect the frame rate or the tick rate at which the game is running. We don't want to deal more damage if the game runs at more FPS. So that's why in some cases we need to deal with the delta time in systems that are related to ticks. But if we want logic that runs when entities appear or disappear, we can use the ref system for lifecycle hooks. For example, for a welcome system. We use the query and say, hey, I only want player refs get component type. I only want this. And then I can say, okay, let's override the onEntityEdit method. And since I only queried for player refs, I don't need to check that in the onEntityEdit listener. I can just say, hey, a player joined, send a welcome message. And on entity remove, I can say, hey, the player left, maybe send a message, hey, we miss you, see you guys later. This is very useful for welcome messages, for initialization, for cleanup, and for tracking joins and leaves. We can also use the damage event system for combat, for example, for intercepting and modifying damage. We can say, okay, check if the entity has armor. And we do that by getting the armor component and checking if it's not null. If it is not null, then we can say, okay, this entity has armor. And then we can, for example, reduce damage by armor value and set the damage amount and can propagate it further. So this is very useful for armor, damage modifiers, invulnerability, and damage logging, for example. So we have different types of systems, and those are not every system that is available in Hytale, just like a quick heads up. And the pattern is, think about when your code needs to run, then pick the right system type. Now I want to explain a pattern called archetypes and why queries are fast. So those are the performance secrets. How does Hytale process queries so efficiently? Well, every entity has an archetype, or archetype, I don't know, a fingerprint of which component types it has. Entities with the same components are grouped together. For example, we have archetype A, B, and C. and they are grouped together. We have all NPCs, all players, or all projectiles. If your query needs player ref, Hytale skips archetypes B and C entirely. So it doesn't have to check every single entity. Yeah, exactly. It skips entire groups. And entities with the same archetype are stored together in memory. That's very cache friendly and very fast. So if you want to look at the memory layout visualization, entities with the same archetype are stored in archetype chunks. So, and you might ask, hey, why does this matter? Well, you will encounter this class in Hytale itself, and it matters when a system iterates over health components, for example. They're all next to each other in memory. The CPU can prefetch them efficiently, and this is called structure of arrays, and why Hytale is so performant in modding. So, at last, let me tell you some honorable mentions for important systems you should know about. For one is the entity stepmat for health and statistics. Hytale doesn't use a simple health component, it has a flexible stat system. So we can get the health stat, for example, from that component, but we also have like mana and stamina and hunger, and all work the same way. Current value, max value, regeneration, modifiers, and so on. And we can also add our own stats to an entity, to a player, to everything that has the entity stat map. So that's why Hytale chose this architecture, so we can easily extend stats for entities, and that's very, very cool. We also have the transform component for position and rotation. So if you want to teleport somebody or get the location or get the rotation, like where the player is headed. So transform component rotation is the body direction, like where the legs and where the body faces. For head direction, where the camera looks, we need to use the head rotation component instead. That's especially important when you want to do a teleport. Then you need to set the head rotation, for example. So one thing I want to tell you is the interaction system. So what about players' actions like attacking or placing blocks? Well, that's the interaction system. And here's the important thing. It's not part of ECS. It's a separate subsystem. And why is it separate? Well, interactions handle the timing of actions, swing animations, charge up, cooldowns. They eventually trigger ECS changes, but the animation timing isn't stored as components. Think of it as, well, interaction means, hey, a player clicked something, the animation plays, at the right moment, ECS gets modified. So, for example, player clicks the attack button, like the left mouse, click thingy, how is it called in English? I don't know. Then the interaction starts, like the swing animation begins. The interaction ticks each frame, so the animation progresses, and at the hit point, only then we do modify the ECS. We add a damage event, the system processes damage, and health components get updated, for example. So we have very, very many interaction types in Hytale. The most common ones are like place block interaction, damage entity interaction, projectile interaction, use entity interaction, and so on and so forth. And interactions are configured in JSON assets. They are not hard-coded. A sword's attack, a ball's draw, a shovel's dig, all defined as interaction chains. So, for example, the damage entity interaction. We have a class and it extends interaction, and we have properties, for example, and we have damage effects and angle damage to look like, okay, how much damage per hit, and so on. And the interaction doesn't directly modify ECS components, as I just said. It describes what should happen. The actual ECS changes happen when the interaction executes at the right moment. So we need to differentiate between systems versus events versus interaction. So a system, like the ECS processor, runs every tick, like a auto heal system heals over time. We have a event, which is a notification broadcast, like a player chat event when someone types. Or we have an interaction. It's a timed action sequence, for example, when a sword swings with an animation. The flow for an attack, interaction starts, at hit point the event is fired, the system processes it, and the component health gets updated. So, to close this video, what we learned. We have a universe, we have a world, and we have an entity store. That's the hierarchy. A ref is nothing than just a pointer to one entity. and the store is the container for all entities. We have a component type, which is a fast identifier for component classes. The read pattern is like for store get component with the ref and the component type. We have the write pattern with store add component. We have queries, which filter for which entities a system processes, and we have archetypes, group entities by component set for fast iteration. We have system types like ticking system, ref system, damage event system, and we have interactions that are not ECS. They handle action timing and trigger ECS changes. So, very much theory. In the next video, we will go hands-on. So, subscribe to the channel, join the Discord, give me some time for more English lessons so I don't make as many mistakes. Thank you all for watching, and I see you in the next video with some hands-on demos.